All right, let's graph this one, e to the power of 2x. And yeah, I'm going to need my calculator for this one. And just to go back, you can use the table feature on this one. I think I'll do it both ways. I'll show you guys using where I create the table. And then we'll show you using the table function on the calculator, right? So that's x and y right here. And I'm going to need a few values on this one. Now, there's no reason to change this into a logarithm. You could. And remember, y is really f of x. The function based on x is y. That's just in function notation to start with. So e to the power of 2x means if I choose an x, it will solve for the y. So yeah, saying x is 0, that's a pretty good one. E to the power of 2 times 0 is just e to the power of 0, which is 1. So I got the point, ordered pairs 0, 1. And yeah, all these ordered pairs in the table, all these pairs in the table are ordered pairs. So that would produce this red dot, which again isn't really enough to graph this, but let's go to the next value, like let's say x is 1 on that, okay? So I'm going to use my calculator to evaluate that, which is e to the power of, it's 2 times 1, which is 2. So I get 7.389, and even graphing hundredths on a graph this small wouldn't be very useful. So I'm just going to round that and say that I got 7.4 on that. Again, that's just from the calculator. So that's 1 and 7.4, which is about right there. Okay. Well, I need a second point, otherwise you just connect the 2 points and make a straight line. So I'm going to say x is 2 on this one, and this is where it can get a little sticky because of the exponent. So let's see, we got e to the power of 2 times 2. You can type that in if you need to. Just put 4 if you'd like. 54.59. See how that's off my graph right there? Right, we got 54, I'm going to say 54.6 on this one. That ordered pair won't fit on my graph. I mean, I know it's way up there, but it won't fit on my graph. So I know it's curving upwards very quickly, and that'd be fine to graph, by the way. So we can show that from this 0.01. That's not a great line. Still not my best work, but it'll do. But I want to see what happens to the left of that red point. So I'm actually going to choose a negative value on this one, so like -1. Okay, so I'm going to have to evaluate this with the calculator again. E to the power of, that's 2 times -1. Enter, and I get this 0.135. So I'm just going to say 0.1, which is about right there. Now we could confirm the pattern by saying, well, x is -2, so that's e to the power of -2 times -2. I'm sorry, negative e to the power of 2 times -2, which is -4, and that's a 0. Really like 0.2 right there, right? Which is even closer to 0. I mean, I don't even know if I can graph that. So pretty quickly, this line gets really close to 0, something like this. And that's good enough for the graph, as long as we remember that this graph doesn't pass 0. Okay, that's kind of the crucial part of this, or that it doesn't like curve this way or that way or come back down, something like this, or even like this kind of stuff, right? So to do this in the table, well, I click the table button, and I am working with TI-30 XS multi-view. So we just type in E, so that's second ln, natural log, and then it's 2 times x. And remember the x, it's just that button to the left of 4. And yeah, like I said, the Casios I don't think would do this for us, but if I push enter, and we'll start at 1, you don't have to start at 1, you can. But if I push enter here, enter, need to get to OK. There we go. Oh, I thought it would produce some values for us.